Welcome you all. In previous session we were discussing this question and we have been asked to calculate how the duration of this project would distribute, what is expected time, what is the probability that the project would be completed in 14 or less than 14 days, and critical indexes of all the activities. And we have to simulate this network for 5 times. We have been given these two activities 1 2 and 1 3 having fixed duration. As far as 2 3 2 4 and 3 4 are concerned, we have been given their time durations along with probabilities, and the random numbers which are to be used for these 3 activities are these, right. So, let us start simulating this network. Since we have to simulate this network for 5 times, we will be simulating it now 5 times. So, first of all, let us go for first simulation run. So, first simulation run, right, and the network is this, right. This is our network 1 2 3 and 4. So, first time, what is the duration of activity 1 2 is 5, right. For 1 3 it is 2. For activity 2 3, random number is this 0.2 and 0.2 is in this range. It means the duration is 3 days. For activity 2 3, duration is 3 days. For activity 2 4, first random number is 0.9 and 0.9 is in this range. It means duration is 8. For activity 2 4 is 8. For activity 3 4, first random number is 0.6. 0.6 is in this range. It means duration is 4. Let us find out what are different critical paths and what is the total duration of this project. So, TE is equal to 0. TE at this point is 5, right. TE at this point is what? From this side it is 2, from this side it is 8, and from here to here it is 12, and from this side it is 13. Let us take TL also as 13. So, TL here is 13 minus 4, 9. TL at this point, TL at this point will be 13 minus 8 is 5, and TL from this side also can be calculated. So, 9 minus 3, that would be 6, but we have to take a smaller value, right. So, 5 is the right TL value, right. TL at this point is, this is 5 minus 5, this is 0, right. So, TL is 0. So, which is critical path? Where you have got T and TL are same, right. So, this is your critical path. This path is your critical path. So, critical path is 1, 2 and 4, and total duration is 13. This is our first run. Now, let us calculate the duration for second run. second run. Same network, one, 2, 3, 4, right. As far as 1, 2 and 1, 3 are concerned, their durations are fixed, right. Now let us look at activity 2, 3. 2, 3, its random number is 0.1. 0.1 is in this range, so the duration would be again 3 for activity 2, 3. This is 3. For activity 2, 4, random number is 0, so this is here, right. So this would be 6, right. 2, 4, it is 6. For 3, 4, random number is 0.2. 0.2 is in this range or in this range? In this range it is less than 0.2, right. So for 0.2 duration is 4. So for 3, 4 it is 4. Let us find out critical path. TE at this point is 0, TE at this point is 5, TE at this point is 5, right. Okay, from this side it is 8, right. Now TE at this point is what? This 8 plus 4, 12, 5 plus 6, 11, so this is 12. So this is critical path. If you want, you can calculate TL also. Let us calculate TL also. So TL 12, this is TL 8, right. So 12 minus 4, 8, 12 minus 6, 6, and 8 minus 3, 5. So TL at this point would be 5 for this node. For node 2, TE is 5 and TL is 5, right. Okay, what about TL here? TL from this side it would be 0, right. So you have got how many critical paths? You got more than one critical path, and the total duration of this network is 12, right. So you have got this critical path, right. This is your critical path, right, and the total duration is 12. So CP is what? It is 1, 2, 3 and 4 with total duration of 12. This is second run. Let us do it for third run. Third run, this is let us say we will draw a network here like this. This is third run, fourth and fifth, right. So we will do it in this particular row, right. So this is third run. Right. This is 1, 2, 3 and 4, right. So there is some problem, I think we did a mistake. In fact, in second run the duration for activity 1 through 1, 2 is 2. For 1, 2 it is 5, for 1, 3 it is 2, right. So this is 2 actually, right. So T will remain same, right. So this is 0, 5, 5, 3, 8, yeah. This is now correct. In fact, this duration didn't affect our critical path as well as total duration, right? Now activity 1, 2, its duration is 5. For 1, 3, its duration is 2. Now what to do? We will take up third random number, right? For activity 2, 3, 2, 3, third random number is this 0.9. 0.9 is here, so 5 is the duration, right? For activity 2, 4, third random number is 0.1, which is 6. For 3, 4, it is 0.9, which is here, right? 5. Calculate TE and TL. So TE at this point is 0, TE here is 5, TE here is 10, right? 5 plus 5, 10, 10 plus 5, 15, yeah, so this T is 15 here, right? TL is 0, TL here is 10, right? Then TL here is 10 minus 5, 5, and this is 15, right? So TL 10 minus 5 is 5, 15 minus 6 is 9, right? So we will take TL is equal to 5 at this node 2, right? Then TL here is 0. Critical path is, it's 1, 2, 3 and 4, right? So this is 1 to 2, 2 to 3 and 3 to 4. What's the total duration? 15 days. So CP, critical path, is 1, 2, 3 and 4, 15. Let's take for fourth time, we will do it quickly. 0, okay, this is your network, 1, 2, 3, 4, this is 5, this is 2, right? Fourth time, this is 0.3, 0.3 is here, right? So the duration would be 4, 2, 3, duration is 4. For 2, 4, random number is 0.5, which is here, right? So duration is 7. 2, 4, 2, 4, duration is 7, and for 3, 4 it is 0.1, it means 3. So TETL 0, this is 9, this is TE at this point is 5. So 9 plus 3, 12. So from both the sides we are getting 12, right? Now TL, let's take TL is equal to this 12. So 12 minus 7, 5, and 12 minus 3, 9. So TL at this point is also 9, TL at this point is 5, right? Now TL is 0. So now you have got two critical paths, right? You have got 1, 2, 3, 4, 1, 2, 3 and 4 and 1, 2, 4. So CP, there are two CPs, 1, 2, 3 and 4 and 1, 2 and 4, and the duration is for both these paths is same, right? 12, right? Let's do it for fifth run also. Fifth run. this is 5, this is 2. Let us calculate for last run the durations for remaining activities. So 0.2 is here, right, 3. So for 2 3 it is 3, right. For 2 4 it is 0.6, right, 0.6 is here, right, 7. For 2 4 it is 7. For 3 4 it is 0.1, right, so it is 3. So T here is, T is 0, T is 5, T is 8, right. This 5 plus 3 8, 8 plus 3 11, 5 plus 7 12. So T at this node is 12, right. TL is also 12. So this is TL at this point is 9, right. 12 minus 3 is 9. 9 minus 3 6 and 12 minus 7 5. So we will take 5 from this path, right. So this would be the critical activity, right, and TL here would be 0, right. So what is critical path? This path is critical path, right. So in fifth case, in fifth run, we are getting just one critical path, which is 1, CP is equal to 1, 2, 4, and its value is 12 days, right. So let us now solve the first question, distribution of T of the project duration, distribution of this project duration, right. So if you look at time estimates over there, we have got 12, 13, 15, 12 and 12, right. So what we can do is the distribution of T. So we know the T and we know the probability also. Since we have done it 5 times, so duration is, let us say the minimum duration is 12, right. How many times you are getting 12? 1, 2 and 3. So 3 by 5, right. Out of 5 times, 5 runs, 3 times we got 12 as the duration, right. Then 13 is how many times? Just one time, yeah, first time, 1 by 5. And 15 is, did we get 15? Yeah, here it is, right. So 15 is for one time. So this is the first part of the question, right, A, distribution of this project, right. Now what is expected time? Expected time, just take the average of all these values, right, and that would be expected time is, since you can also find out probabilities here, 0.6, 0.2 and 0.2, right. So what is the expected time? You just multiply 12 into 0.6 plus 13 into 0.2 plus 15 into 0.2. So this would be 12.8. So this is the duration of this project, right. The expected duration of this project is 12.8 days, right. The third point is, what is the probability that project will take less than or equal to 14 days? Less than or equal to 14 days. How will you do that? Probability that the project would be completed in less than or equal to 14 days, right. So for that, less than or equal to 14 days, right. This is for 15 days, right, 0.2. This is for 12, 13. So for less than 14 is this, right. So this is 0.6 plus 0.2, right. This 0.8 is the answer. Now the next part is critical index of all the activities. Now, since there are different activities, we will have to find out critical, how many times which activities were critical, right. So, let us look at D part here. So, we did run, we did go for 5 runs, right. So, first, second, third, fourth and fifth, and let us write here different activities. So, let us say activity 1 2, activity 2 3, activity 2 4, activity 3 4. You do not have any other activities, right. You got only 4 activities or 5 activities. It is 1 2, 1 3, 2 3. Yes, it is 1. Yeah, there is. So, this is 1 2, 1 3, then 2 3, 2 4 and 3 4. There are 5 activities, right. Now, let us find out which activity was critical, or which activities were critical in first run. In first run, you have got 1 2 and 4, 1 2 and 2 4 critical, right. In second run, you have got 1 2, yes, 1 2 was critical, 2 3, 2 3 and 3 4, right. This was also critical, right. Third run, you got 1 2, 2 3, 1 2, 2 3 and 3 4, 2 3, 3 4, right. Fourth time, 1 2 was critical, then 2 3, yes, 2 3 was critical, 2 4, 3 4 both were critical, because there are 2 paths here, right. Fifth time, 1 2 is critical and 2 4 critical. So, out of 5 times this was critical 100% time, right. This was not a critical even once, right. Out of 5 times this was critical for 3 times, it means 0.6 is the critical index. In other words, 60% times this would be critical, this also 0.6 and this also 0.6, right. So, this is the fourth part of this particular question. Now, let me repeat what we did in this session. Let me try to summarize what we did in this as well as in previous session. As I said, in real life you will not know exactly what is the time of an activity. It may take any shape, it depends on different factors. Let us say if you are constructing a bridge and you know that a particular activity takes, let us say, 5 days time, right, from your past experience, but next time it is possible that due to non availability of some resource it may take 10 days, right. So, it is very difficult to predict the duration of the activity. So, the simulation is the best method. Why simulation is best? Because you can always prepare a computer program and simulate an activity for thousands of times, right. In fact, if the duration of the activity is, let us say, distributed, let us say it has got beta distribution, right, or it has got normal distribution or some flat distribution or triangular distribution or some other distribution. it is always good to simulate it, right, but you need to simulate in certain situation, and there is only one specific situation, it is uncertainty, right. When you think that situation is very uncertain, you should simulate, right. And for simulation you need to know something about random numbers, and random numbers can be generated in different ways. You can always ask me a question, from where did I get these numbers, right. So there are multiple methods of generating random numbers. The first and the most easiest method of generating random number is you got random number tables. In all the books of statistics and in the books of mathematics also, sometimes you will have a random number tables. So from those tables you can pick up random numbers, and random numbers can be of different digits. You can have a single digit random number, you can have 2 digit random number, you can have 5 digit random numbers, and so on, right. If you do not have a random number table, then you can simply prepare chits, and let us say if you want to pick a random number between 1 to 10, so you just prepare 10 chits and pick one chit, right. So that chit would give you a random number. So this second method. There are several computer programs available for generating random numbers. Apart from this, you would have seen there is something called roulette wheel, right. You would have seen in movies also, right. So roulette wheel will also give you random numbers, and there are some mathematical methods available which will also give you random numbers. So there are multiple ways of generating random numbers. The moment you select a set of random numbers for particular activity, for example, for this activity we have chosen these 5, and each time we got different time estimate, right. So the moment you change random numbers, your solution will also change. So it is suggested that you should generate more and more random numbers, and you should perform more and more simulation runs. As far as this particular question is concerned, we did go for 5 runs, and in first run, since in this particular case 2 activities have got fixed durations, right, 5, 5 and 2. For all other 3s we have been given random numbers and their time estimates along with probabilities. So in first random number, what we did, we calculated all T's and TL's, and the critical path is 1 to 4, right. So only 2 critical activities, the duration is 13. For second run there were 3 critical activities and the duration is 12. For third run there are again 3 critical activities, this is 1, 2, 2, 3 and 3, 4, total duration is 15. Fourth run there are 2 critical paths, in fact in no other run we found 2 critical paths, but in this run we have got 2 critical paths, right. So this is 1, 2, 3, 4 and 1, 2, 4, total duration is 12. In fifth run you have got again 2 critical activities, 1, 2, 4, right, and total duration is this. So what we have said at the end of the day, that probability that this project would be completed in 12 days is 60%, it would be completed in 13 days 20%, it would be completed in 15 days 20%, right. So 15 by in fact since we got this only once, so this 1 by 5, 1 by 5 and 3 by 5 for duration, this one, right, for this duration, right. Expected time, you just multiply their durations with the probabilities, so it is 12.8. So at the end of the day we will say that the duration of this particular project is 12.18, probability that it will take less than 14 days it's 0.8 and this is critical index. So, we will say that in this example the most important activity is activity 1 2. So, whenever you go for a run, this in as far as these 5 runs are concerned, activity 1 2 was critical. So, with this let me finish here. Thank you very much. We will have some more topics in next session. Thank you.